Welcome back. Now assume that A and B and C are bigger than 0. We want to prove that A plus B plus C times 1 over A plus 1 over B plus 1 over C is bigger than 9. Here there are many techniques to prove this result, but we're going to use algebra to prove this one. We're going to use a result that we will have to prove first. So this result is that given some x, let's assume that x is bigger than 0. We're going to prove that x plus 1 over x is greater or equal than 2. How can we do that? So since x is positive, we can multiply both sides by x. Once we do that, we're going to have x squared plus 1 bigger than 2x. Okay? And if we add 2x or minus 2x to both sides, we're going to have x squared minus 2x plus 1 bigger than 0. And this will give us x minus 1 bigger than 0. And this is always true. Okay? Or if you don't like this proof here, we can start from here. We can say that x minus 1 is always bigger than 0. So this is a square and it's always bigger or equal to 0. And we can expand it, so we can have x squared minus 2x plus 1 bigger than 0. Okay? And now we can add 2x to both sides. We're going to have x squared plus 1 bigger than 2x. And since x is positive, we can divide everything by x. We're going to have x squared plus 1 over x bigger than 2x over x. So here we get x squared by x is x plus 1 by x. It's 1 over x bigger than 2. And this is what we need. Okay? Now we're going to use this result. Remember that if x is positive, x and its reciprocal, it's always bigger than 2. Okay? So now we're gonna use this result here. We're gonna decompose this result and use this fact here that x plus 1 over x is bigger than 2. How can we do that? Okay, let's expand this one here. So here we have a plus b plus c times 1 over a plus 1 over b plus 1 over c. So here it's going to be a times 1 over a, which is 1, plus a over b plus a over c plus b times 1 over a, which is b over a, plus b times 1 over b, which is 1, plus b times 1 over c, which is b over c, and plus c over a plus c over b plus 1. Okay? So here, so this is 3, it's 1 plus 1 plus 1 plus a over b plus b over a. So this one with this one plus a over c plus c over a. So this one with this one plus b over c plus c over b. Okay, so this is what we want to prove. Okay, so we have to prove that this one is bigger than 9. Okay, so now if we subtract 3 from both sides, we have a over b plus b over a plus a over c plus c over a plus b over c plus c over b is bigger than 6. So we have to prove this one. Okay, so we have to prove this result. Now we're going to use this key idea here. Note here, if we take x as a over b, then 1 over x is just b over a. Okay? And here, if we use x as a over c, then 1 over x is c over a. The same thing here, if we use x as b over c, then 1 over x is c over b. Okay? So using this result here, we have a. So we're going to prove this result now. Okay? So this is the same as this one. Okay, so here we have a over b plus b over a is bigger than 2. How do we know this? We apply this result here to x equal a over b. We apply this result here. And we have b over c plus c over b is bigger than 2. And we have, what's the last one? So we have a, b, c, and we have a over c plus c over a is bigger than 2. If we add these three, okay, side by side without changing the order, all of them are positive. Okay, note here that this is never 0 because b is never 0, a never 0. The same thing for c. Okay, once we add all these numbers, we're gonna have this result here. Okay, and that's what we had to prove. Okay, so this is a quick way of proving this result. There are other ways, like the arithmetic geometric mean, but for someone who doesn't know that we can use just this algebra, key algebra ideas to prove our result. Okay, so note here that we have used this fact that we had to prove. This is very important in proving some other results. Okay, and this proves what we need. Thank you very much.